welcome. We are going to look at equations of a circle today. I think I already talked about, if you look at the quick explanation, it kind of goes further into why the circle is what it is. So I'm going to kind of get right into problems in this part. So if you want to know the explanation or how, I kind of explained it a little more on the video that says quick explanation right next to it. So this is more just examples and what the equation looks like. So set 10.7, right, and you graph equations of a circle. If you understand the concepts, the problems are actually pretty straightforward. So equation of a circle, let's get right to it. It looks like this. It looks really fancy. It's not. So x minus y minus k squared equals r squared. Okay. Basically, to get the equation, you need h, k, and r. Okay. Well, I'll give you the hint here, or not the hint. The center. That's not right. The center is h and k. Okay. Guess what r is? Good. Radius. Okay. Remember, now note it's radius squared, so you need to square it when you're given it to write the equation. So note it's x minus h and y minus k. Okay. So I'm thinking of the Yankee Doodle song in my head, so I gotta rethink what I was thinking. Oh, so x minus h squared y minus k squared equals r squared. So you need h and k, and it's minus k. So if this was x plus h, let's just say plus, that would mean whatever this number is, it would actually be minus that number to get the actual number. So let me just give you a really basic look at this. So here would be example. I'd say x minus 3 squared plus y minus 2 squared, and get, let's just say this is 16. Okay, my center would be 3, 2. Hey, I'm teaching, so then r would be square root of 16, which would be 4. So that would be my center. This would be my radius. To graph this, I would just say 3, 2. 1, 2, 3, 2. There it is. 3, 2. That's my center. And then up 4, down 4. So I'd go, easy way to do this, go down 4, 4, over 4, up 4, and over 4 this way. Another reason I do that is to make this picture easier to graph. And that's close enough to a circle. Yikes. So that's the general gist. Now, like I said, if this was plus 3, it would change the problem completely, because this would actually be a negative 3. And this center would be over here, and we would draw everything again. But that's not what the problem was. I just want you to understand that if it's a plus, it's really the opposite sign that's happening here. Okay. Now, if you look at this closer, yeah, let's just get rid of all this. If you look at this closer, you might remember that old Yankee Doodle song. Draw a long square root sign. X plus x2 minus x1 squared plus y2 minus y1 squared. Yada yada yada. If you do that, you have to look at that and how it compares. X2 minus, right? Y2 minus. It's amazing how that stuff sticks in your head. Square root equals your distance. Well, notice this, the distance formula and the equation of the circle formula, they might look the same because they are, which is something that's pretty. I think if you look at how these compare, it's basically the same. The only difference is this square we keep out here because it looks prettier. You don't have to draw this ugly square root sign, because really I could just write d squared, but we usually want to solve for d, so then we take the square root of it, get rid of the square root, or not, get rid of the square, and then find the square root. And that's why we have it looks like this, as opposed to this. Or, come back. Yikes. Mess. As opposed to this. So, anyway, we'll look at a couple more problems, and hopefully this will make sense as we go. So, again, where that comes from is if I were to do this, put a point here, 0, 0, that's easy. You don't have to write this down for once. This would be my radius. And now, remember, a circle is just an infinite number of points away from a given center. So, infinite number of points all around this. I could draw this line anywhere, right? Terrible radiuses all around. And then I would solve. Well, this distance is x, this distance is y, and this is r. Hey, I'm just making a quick video. So you get x squared plus y squared equals r squared. And that's pretty much so again, this looks very similar to the Pythagorean theorem because it is, and looks very similar to this because it is. So let's just graph the circle real quick, and then I'll let you on your way. That's not what I want to do. Graph. Actually, I'm going to bring this picture over here. Here is this real quick. You can look at, yeah, you see it. Let's see here. Bring this over here. Nope, that's not what I want. Actually, let's do it the other way. Like this. Bring this here. Okay, so again, match, just basically being a matching game. What's H? It's 4. What is K? It's -2. And R is 6. You take the square root of 36. So the graphing is pretty easy. 4, -2, and then up 6 if I can count that high. Here we go. Over 6, I'm running out of space. Somewhere over here. Down 6. And I don't know why I have that circle there because it's going to really confuse you. I meant to just have the graph. Let me move that out of the way in a second. Just getting it uglier and uglier. There we go. So, again, ignore that circle. So I go over 4, down 2 to find the center. And then up 6, over 6, over 6, and then just play the matching or connecting the dots game here. Okay. And that's it. So that's basically the gist of how to graph. The graphing is usually pretty easy.
Hello, Mr. Rubis. How are you?
Hello. Just doing a quick video for you guys. So, give me a second. So here's the tricky ones. We have this. We have this. The center. How do I find the distance? Hint, hint, wink, wink. Find the distance from there to there. That would be your radius. I know what the center is. So if I say x minus h squared plus y minus k squared equals r squared, I can easily find the center. So I say, here's my center right there. So I'd say x minus -1 squared plus y minus 3 squared. Remember, if this is the center, again, the center, we just call that h and k. I can't give you a good reason why they chose h and k, but they did. So, plug it in, x plus 1 squared plus y minus 3 squared equals r squared. We need to find r squared because we don't know it. We know it's the distance from there to there, and except from guessing, or I guess you could cheat a little bit and say just count the lines out, but we want to be sure that that's right on the edge, so we're going to actually find it. So you're almost there, because again, the form, if you look back at it, is x minus h squared. Looks like this, and it's actually in this form. It's not actually solved. You don't have to do anything special from there. You're done at that point. So we need to find the r, so we're going to do that quick. We're going to use the distance formula, so minus 5 minus -1. I don't know why I'm writing everything wrong here. -5 minus -1 squared plus 6 minus 3 squared equals d, the distance. I want to find the distance, which is, again, distance formula gives us what the radius is, because how far is it from here to here? Use distance formula. So we solve, we get -5 plus 1 squared plus 3 squared. Alright, handwriting's getting messier because I'm rushing. So this is -4 squared, which is 16 plus 9. Oh, let's look at this. It is going to be something even. What's the square root of 25? 5. So I go back, I plug in. I'm going to erase some stuff. You can pause if you need to. I'm going to plug in this 5 I just found, because that's the distance. I want that here. So I plug in the 5 I just found. I get x plus 1 squared plus y minus 3 squared equals 5 squared. So then, to finish up this problem, I write all this mess again. You don't have to write this every single time. You can skip to this step if you feel comfortable with it. Equals 25. And this is the answer. This is the equation in simplest form. You can't leave the 5 squared, or I'll take points off and say mean things about your cousins. Because that just doesn't make sense. You won't actually know what this is, because you know what it is. So you write it down in terms of what you know. So you know, if you look at this picture now, you know the graph, the center is -1 and 3. You know the radius is 5. You should take the square root of this. And that's just the standard equation. Again, to kind of recap, because I kind of rushed through that, what I did was this. We looked at everything, go all the way back. we said, okay, whoa, that's too far. Stop, computer, slow down. Stop it. Stop. There we go. So you find the distance. We know what the center is, so we plug that in right away. I plugged it in. Then I find the radius. Okay, I find the radius. And then to find the radius, I need the distance formula. So I use the distance formula. And as I use the distance formula, all I'm doing is x2 minus x1. I just use this as my x2, this is my x1. Plugged it in, went from there, solved for d, which was my radius. I plug the radius back in, write the equation, and say I'm really smart. Last one. Okay, look at this. Here's the center. So I find it out. 10, 20, 30, 40, 50. Please note it's 10, scale is 10. So it's 50, and then 10, 20, 30, 40, 50. So it's this point right here. The center of this graph is 50, 50. So I do x minus 50 squared plus y minus, oops. Let me go back even further. Here's your equation. I am almost there. Squared equals r squared. So there's the standard equation. Yes, you have to remember it. Yes, take some time to think about what it is. Again, it's just the distance formula, but with just the r squared. So my center is 50-50, so I just plug in the center, which is, again, this equals h and k squared plus y minus k 50 squared equals whatever my radius is. Well, how far is it from here to here? Oh, look, it's 10. So this is really 10 squared. And then to write it succinctly or completely or something like that, one of those words, y minus 50 squared equals 100 squared, or not 100 squared, 10 squared, which is 100. And that's pretty much the gist. We will talk about completing the square probably in a later video, but that's it. So thank you for watching.